well, as long as you, doing the factor tree, can circle pairs. So, if we look at the square root of 160, okay, what two factors did we use? 16 and 10. What's the square root of 16? 4 root 10. If it's a perfect square, the radical disappears. Whatever's left over stays inside. Okay? How about the square root of 72? Josh? 36 and 2. Good. And what are we left with? What's our final answer? 6 root 2. Good. Even if you did 9 and 8, okay? If you did 9 and 8, which some of you did, you got to this point. Can 8 keep going? What does 8 break up into? And then what? If I was to do the factor tree. Is this. So I'm looking for pairs. 3 is already on the outside. Here's a pair of 2's. Whatever's left over stays inside, and then you multiply. So you end up with the same answer. So square root of 8 can be simplified to 2 root 2. If you have square root of 20, 2 root 5. Okay, so those types, square root of 12, 2 root 3. Those can keep going. Okay, John, you have a question? Okay. How about C? Go ahead, John. Perfect. We already have the 3 on the outside. We have 25 root 3. Square root of 25 is 5. 15 root 3 is your final answer. Okay. How many of you do remember simplifying radicals? Okay. Some do, some not. Okay. Just trying to gauge to see, because you've seen it probably sprinkled throughout, but not actually taught a full lesson on it, possibly. Okay. So now we move on to variables. Okay. There's a bunch of ways we could do this. Okay. You could expand these out, and what I mean by that is there's x to the 9th. So how many x's do you have? X to the 9th is how many x's? 9. And since we're looking at a square root, we're looking for pairs. Okay? So I have one pair. For every pair, an x comes out. This is one way. There's several ways. Another pair. Another pair. Another pair. Whatever's not circled stays inside. And now I multiply. What is x times x times x times x? Brian? X to the 4th root x. Okay. Another way you could do this is 2 goes into 9 how many times? 4. How many are left over? There you go. Okay. Instead of expanding out. Okay. X to the 6th, y to the 7th. 2 goes into 6 how many times? So that gets rid of our x's. 2 goes into 7 how many times? How many are left over? Okay. You could expand this out and circle pairs if you need to. But I also want you to know that part, because if you have x to the 100, are you going to draw out 100 x's? No. Nor would I want you to. Okay. So in C, we have x squared already on the outside. Now, square root of x to the 8th would be what? Josh? Good. And square root of y to the 10th would be what? You? Y to the 5th. Is there anything left over inside? No. So what do I do here? Josh? Simplify, how? Mm-hmm. Perfect. Good. Okay. So anytime you're multiplying with exponents, you add. Okay. Any questions about those three? Now we're going to combine everything together. Okay. X cubed root 54x. What's the only thing you could simplify? You have x cubed still on the outside. What are two factors of 54? Yeah, Grace. Good. What's the square root of 9? Can I do anything with the square root of 6? Or the square root of x? There's no pairs, so you multiply those together. Okay, I broke it up into individual. However, you could do the factor tree as well. Try B. All right, what do I have for B? Corey? Good. 4x to the fourth root x. Good. Because the only thing there, square root of 36, is 6. Can't do anything with the x. Okay. Now C. We have x squared already on the outside. How does the square root of 18 simplify to? Yeah, Brian. 9 and 2. Okay, what's the square root of 9? Can I do anything with the square root of 2? And square root of x squared? X, good. And now I'm left with okay. Okay, I want you guys to try D and E. Okay, try D and E. All right, for D, what do we have for an answer? Q? Perfect. 9x cubed square root of 3. How many of you did get that? Okay, we have 3x, and the square root of 27 is what? 9 and 3. Okay, square root of 9. Can't do anything with the square root of 3. Square root of x to the fourth. So whatever's not circled or no pairs stays inside. And now we multiply. 3 times 3 is 9. X times x squared is x cubed. Okay. How about E? Rory? Good. Okay. We have negative xy squared. What are two factors you use? Okay. We have negative y squared. Square root of 16 is 4. I can't do anything with the square root of 5, so that stays in. Now, square root of x to the 9th. 4 goes into 9, 2 goes into 9 how many times? Go ahead, Brian. 4, therefore 1 is left over. 2 goes into 5 how many times? twice. How many are left over? Okay, so now we multiply. Negative 4, x to the 5th, and the 4th, 5xy. That's exactly correct. Okay. Any questions? Okay. Then we move on to adding and subtracting. Okay. Adding and subtracting, they have to be like terms, meaning same radicals. So if it's the square root, which is what we're going to see, has to have the square root of the same number inside in order to combine. So for example, 5 root AB plus 6 root AB, these are like terms. So I could just add the coefficients. So I'm left with 11 root AB. Okay. It's the same thing as if we had 5x plus 3x. We end up with 8x because I could combine like terms. Okay. How about B? What would I get? 12 root 2x minus 3 root 2x. Yeah. 9 root 2x. Okay. A non-example where you can't combine like terms is like that. Okay. Just like if we had 5x plus 3y. You can't combine those guys. Okay? So there might be a situation where the radicals aren't simplified completely. Okay? You can't combine those at all until they're like terms, if there are any. So you need to have them in simplest form first. So 4 root 12, what can that simplify to? Yeah, Roy. What was it? Okay, because you have 2 root 3, which is 8 root 3. 6 root 3, I can't do anything for. And how about square root of 27? Yeah, Andrew. Minus 3 root 3. So now, all of our radicals have like terms. What do I end up with? John? 11 root 3. Good. Okay, I want you guys to try some practice at the bottom. 1 through 8. Okay, 1 through. Also, number 2, you're just adding or subtracting, 21 minus 4, 17 root 21. Okay. Number 3, nice job. 24 root 13 minus 4 root 7. Okay. For number 4, we have root 2 minus, how do I simplify the square root of 8? What does that come simplify to? Yeah, Andrew. 2 root 2. What is the coefficient in front of this? 1. What's 1 minus 2? Negative root 2 is your answer. Okay. Because in the number in front of root 2 is 1. So you're just simplifying 1 minus 2. Okay. Then number 5, if you had 3 root 2 plus 2 root 3, that is correct. Okay. This is also correct. Number 6, 27 root 7. Number 7, that's as far as you could go. Number 8, we have 22 root 5. How do I simplify 9 root 75? 9 root 75. How do I simplify that? Yeah, keep. Okay, and 5 root 3 times 9? 45 root 3. Okay, and then we have minus 25 root 5. Okay, so we should have negative 3 root 5 plus 45 root 3. How many of you guys got that for that last answer? Any questions on 1 through 8? Andrew?
Number 6.
Yep. Sure. Okay. So you have 10 root 63 minus 2 root 28 plus root 7. Okay. How do you simplify square root of 63? 7 and what? It's okay. You looked at 28, I think, at the same time. Okay. So this is 3 root 7. This is 2 times 2 root 7 plus root 7. So we have 30 root 7 minus 4 root 7 plus root 7. And that's how you get the 27 root 7. Okay? Any questions on those? Okay. The next is multiplying. Okay? When you are multiplying, you can multiply outside first and then inside, okay, and then simplify. There's a bunch of different ways. So for example, for this first example, I can multiply 2 times 6 to get 12, and then I have root 15. That I know can't be simplified, so I leave it as is. Okay. Now if I look at B, I could do this a variety of different ways. And you guys tell me which one you want to do. Do you want to simplify first each radical and then multiply outside and inside and see if we could simplify again? Or write it under 1? It's totally up to you. So if you were to write it under 1, then you multiply the outside, negative 6, then you have 40, x times 56, x to the 5th. If you wanted to multiply 40 times 56, you're just back to square 1. So from here, 2 factors of 40 are what? 4 and 10. 2 and 2. 56, 2 factors. Wow. Yeah, Jules. 7 and 8. Okay. So right now I'm just focusing on the numbers. Okay, and again, variety of different ways to do this. For every pair, one's going to come out. So the 6, I just carry down. I have a pair of 2s. I have another pair of 2s. Okay, can I break out anything else? John? The 10. And what else can I circle? 2 2s. So another 2. So in terms of numbers, what is left over? What numbers are not circled? Yeah, Brian. Anything else? Yep. So I can multiply those guys together and get what? 35. Okay. Now I'm looking at, I have x and x to the 5th. How many in total do I have? 6. So what can come out of that? Brian? X to the 3rd. So all together, negative 6 times 2 is what? Negative 12 times 2? Negative 24 times 2? Negative 48 x cubed root 35. And again, there's a bunch of different ways. We could have simplified separately, then multiply outside and inside, but you probably have to simplify again. This is just one way. There's plenty of others. Okay? Yeah? Because we have x and then 5 here, so we have 6 in total. 2 goes into 6 how many times? 3, and there's nothing left over. Okay? So if we look at numbers, and I'll do this the other way. Thank you. If I was to simplify separately, 3 root 6 I can't do anything with. How can I simplify the square root of 18? Yeah, right. 3 root 2. Okay? So from this point, I can multiply. So 3 times 3 is 9. Then 6 times 2 is 12. But can I keep going? How do I simplify the square root of 12? John? It's okay. Yep. Okay, because we have 2 root 3, which comes out, right? That simplifies square root of 12. And then I multiply 18 root 3. Okay. So this is another way. I could have done on this one, just wrote it under 1. And as soon as I saw a pair, I could take 6 out. There's so many different ways. So many. Okay? I want you to try B, C, and D. Go ahead. Whatever way you want. Quickly before lunch. For B, what did we get? Rory? What was that? For B here. Okay, can 98 be simplified? It can. Okay, for B, what do we have? Anyone have another answer? Caden. Campbell, sorry. Thinking of my other class. 42x root 2x. Because square root of 98 is 49 and 2. Okay? 42x root 2x. How many of you did get that? Okay. Not a lot of hands. Why not? Answer or else we stay here. So why didn't we get 42x root 2x? About a handful of your hands went up. Hope you guys had a good lunch. Let's go through and finish up C and D. Okay, for C, what did we get for an answer? Anyone want to give it a try? See what we get? Nobody. Okay, so if we rate it under 1, okay, 9 could break up into 3 and 3. Okay, for every pair, 1 comes out. So I have 3, A, I have another pair of A. Whatever is not circled stays inside. Okay, so 3 A squared root 2. Okay. How many of you had that for C? Okay, good, great. Okay, and then D. Sometimes for you, we could multiply 2 times 9 again, but then you're back to square 1. However, if you look at D, we multiply outside to get 21. Then, knowing what is 5 times 20? 100. Is that a perfect square? Yeah, okay. So we'll get to that in 1 second. Then we have this x. Okay? And one more. So, what's the square root of 100? 10. Then we're looking for pairs. 1, 2, 3, x cubed. 210 x cubed. How many of you guys got that one? Okay. Any questions so far? The next two are binomials. Okay, the next two are binomials where you have to use FOIL. Okay, sometimes you might be able to simplify them further, but most cases not so much. So we multiply. 2 times 6 is 12. Then 2 times root 3 is just 2 root 3. Then we have 6 times root 7. And then your last is root 7 times root 3 is root 21. In this case, that's as far as you could go. We can't break it down even more. Okay? We cannot combine these guys because they're not like terms. Okay? Let's try the next one. What is 10 yeah, Andrew.
So are you able to just multiply the square roots like no matter like what's
Because when you're multiplying, you could end up with whatever kind of number. If they were different radicals, say one's a square root, one's a cube root, you can't.
Okay.
But you guys won't see that. So 10 times 10, 100. Then 10 times negative root 3, negative 10 root 3. Then we have 10 times root 6. Then we have negative square root of 18. Any one of those terms, can anything be simplified? Andrew? To what? Good. And the reason we simplify is because we're not sure if we could combine it anywhere else. Okay? And that's as far as you could go for those. Okay? So there's a few practice I want you to complete. We're going to go over them 1 through 9. Okay? 1 through 9 on the practice here. The next case is the denominator. Okay? When we're dividing. This is on page 4. Okay? When we are, first of all, simplifying fractions. So on mine it's down here. You guys have it on the next page. Okay, when you have fractions, okay, the rule is if you have an entire fraction underneath the square root, you could write it as the square root of a over the square root of b. Okay? So, for example, you look to see if your radicals can be simplified first. So underneath, meaning the fraction. So 64 divided by 49, that cannot be reduced. So therefore, we split it. Square root of 64 over the square root of 49. What is the square root of 64? What is the square root of 49? Yeah. Okay. So you're able to simplify. Okay. If you can, by any means, simplify a fraction first, then do so. So before we look at B, look at C. Can you divide 144 divided by 9? What do we get? Okay. What is 144 divided by 9? Yeah. 16. So here's a case where you could do it that way, where square root of 144 is 12, over the square root of 9, which is 3. 12 divided by 3 is 4, right? Or we could look at 144 divided by 9 is 16. Square root of 16 is 4. Okay? Now what changes if you have variables? Okay, looking at the fraction, ignore the square root for now. 8 over 50, can that be reduced? 8 over 50, can it be reduced? Is there a number that goes into both of those? Yeah, 2. So that means 4 over 25. Now, I have 3 x's on top, 1 on the bottom. Can I cancel anything? Yeah, Josh. An x. Now, the reason we do this, so we're not rationalizing everything. So I have 4 x times x over square root of 25. What is the square root of 4? 2. And I could take out an x. What's the square root of 25? 5. 2x over 5. Okay. If we look at the next one, can we simplify anywhere? That fraction first. John? So I have 9 here. And then what? Okay, I have 36 divided by 4, which is 9, right? So I have 1x on top, 1, 2, 3 on the bottom. So I could cancel out, which you were going to say, the x. So now, square root of 9, square root of x squared. What is the square root of 9? What is the square root of x squared? There you go. Try that last one. Try e, if you haven't done so yet. Yeah. What is square root of 25? Square root of y cubed. What is it? What's square root of y cubed? Y root y. And square root of z squared would be what? Z. How many of you did get that? Okay. About half of you without hands up. Josh? Thank you. Root 3. So what is root 2 times root 3? Root 6. And then root 3 times root 3 is just what? 3. Good. Okay. Some people may ask, can we simplify those? You cannot. There's no radical over the 3, so you cannot simplify. Okay? Now for C, one point of advice is you want to simplify your radicals wherever you can first. The reason is, in the end, you would have to simplify again. Okay? So square root of 7 we can't do anything with. How can I simplify the square root of 8? We should know that. 4 and 2, and then what would it be? 2 root 2. Square root of 8 simplifies to 2, square root of 2. That x stays in. So what is the only thing I have to multiply by? Can't have a radical. Grace? Square root of 2x. Oops. So, what's root 7 times root 2x? Root 14x. Now this 2 is already on the outside, so I'm just going to bring that down. What is root 2x times root 2x? What are you left with? Which is? Number inside, 2x. Some of you did say square root of 2x times square root of 2x is square root of 4x squared, which square root of 4 is 2, square root of x squared is x. So you end up with whatever's inside. Okay? Try D and E. Okay, for D, what's my answer? You. Perfect. Over 6x. How many of you did get that? Okay, how do we simplify the square root of 18? Laurel? Okay, so 3 root 2x, okay? Then we multiply top and bottom by root 2x, and that's how we get 5 times 2x is 10x. The 3 is already on the outside, and we multiply by 2x, and we get 6x. Good. How about E? Yeah, Andrew.
Root 21x.
Perfect. Root 21x over 6. How many of you did get that? Okay. How do I simplify the square root of 12? 2 root 3. And I only have to multiply by root 3, top and bottom. And that's how I get. Now, some of you are probably asking, well, or thinking, can I multiply top and bottom by root 18x? Yes, you can, but you have to simplify further. You have to simplify further if you were to do that. Okay? That's the only thing. Any questions on those? The last two for today are, you have a radical in the denominator. However, what's different about it? Yeah, Brian? There's no radical in the top, right? But there is a radical in the denominator, but it's together by an expression. So, you have the square root of 5 minus 1. Okay? We don't have just the square root of 5, where we would then rationalize. Here we have to do something different. We have to multiply by the conjugate. Which is the opposite. So, you're multiplying top and bottom by root 5 plus 1. Root 5 plus 1. So the only thing that changes is the number in the middle, or the sign in the middle. Okay? So you have 3. This is what it looks like if I put it all together. This is what it looks like as an entire fraction. You're multiplying the top and bottom by root 5 plus 1. Now, what do I have to do in the numerator? Distribute. So I have 3 root 5 plus 3. What happens in the denominator? Yeah, good. FOIL it. So what's root 5 times root 5? 5, okay. Root 5 times positive 1. Root 5 times negative 1. Negative 1 times positive 1. Negative 1 times positive 1. What happens to those middle terms? So 3 over 5 minus 1, which is? That is it. Okay, and the last one you're going to try B. What are you multiplying top and bottom by? Brian? That first sign doesn't change. Yep, good. Go ahead, you guys. 9 minus root 2.